Okay, I had a question from one of the students about problem 61 in section 3.2. Now, at that time, we were looking at a problem like this. I need to stay on this page where I made these notes, but the function that we were trying to take the derivative of was f of x equals 9 over x. All right, now later in section 3.3, this would be a very simple problem. But for right now, when we have to do it using the limits, it's a little bit messier. I mean, we have this definition of how to do a derivative in section 3.2. It's that the derivative of x, namely f prime of x, is the limit as h approaches 0 of this fraction. Now, the denominator of the fraction is just h, and the numerator of the fraction is just f of x plus h minus f of x. So here we plugged in x plus h and minus, and then we subtracted the value for f of x. That in and of itself is not such a big deal as putting that substitution, but then the stack of fractions becomes really tricky to evaluate. I mean, what we had to do there is up there in the numerator, we had to find a common denominator. So I had to figure out how to add these two fractions together. And the way I did it is take the first term and multiply it by a fancy way of saying 1, namely x over x. And then in that second term, I had to find a fancy way of saying 1, so I multiplied it by x plus h over x plus h. And this is handy because now both of these terms in the numerator have a common denominator. We can easily add them together. Now, just because it's kind of a mess with this h down here, how there's a giant fraction going on, what I did here is I just pulled that h out in front and made it 1 over h. I wouldn't have had to do it, but it was getting kind of messy. All right, then this expression here that used to be the numerator is now just the whole thing. And you can see I did some simplification, and in fact I can do further simplification because 9x minus 9x is just 0. So my numerator is now just negative 9h. And hey, this h up here in the numerator cancels with this h down here in this fraction, leaving us just negative 9 in the numerator and this expression in the denominator, which could still be a mess, but in this case isn't, because it isn't like as h approaches 0, we're having a 0 down here in the denominator. As h approaches 0, x plus h just gets closer and closer to x. This expression in the denominator, x plus h times x, just gets closer and closer to being x squared. So this limit just evaluates to negative 9 over x squared. And that's our answer. That is the first derivative of f with respect to x. Now, we could have, if we had already seen section 3.3, we could have just used the power rule here, and we could have seen how the same expression there, 9 over x, which is our original function, we could have rewritten that as an exponential, 9 times x to the negative 1 power, and well, its derivative is, we take this power and we bring it down here in front, so negative 1 times 9 is negative 9, and then we take this exponent and we subtract 1 from it, and we put it over here, so it's negative 9x to the negative 2 power, which is exactly the same as this expression right here. All right, so I can send you this document if this works, and I will look forward to getting any questions. Now, there was a second question that a student sent me. I think it was number 63, but it was a very similar problem. Let's see if this information gets you what you need. All right, let me know if you have any questions.